Howdy folks, it's Mr. Ryan again, and what we're going to do in this video is we are going to talk about solving linear equations. Okay? Linear equations are sort of the introductory level equations that we learn how to solve in math. And what I'm going to do first is I'm going to explain to you what a linear equation is. I'm going to explain to you some techniques for solving linear equations. I'm also going to explain some general strategies for solving any kind of equation. And we're going to start with one-step linear equations so that you can have a general idea of the basic techniques. Then we're going to go into multi-step equations, and then we're going to do a variety of different kinds of multi-step equations, linear equations, so that you can see a variety of different kinds of situations that you might face while you're solving linear equations. And then at the very end, after I'm done explaining linear equations, I'm then going to explain what are called literal equations. But I may do that in a different video. We'll see. We'll get to that in just a little bit. Okay, so the way we're going to start is we're going to start with something really, really simple. Let's say that we have the equation t plus 2 equals 9, and we want to solve this linear equation. Okay, now, you may be somebody who's really young, early in school, and you don't really know the technique for solving this. Maybe you already know the answer, and that's fine too. Or you're somebody who has done math a lot, and you can solve this very easily. In fact, you may have solved it as I was writing it down. But here's something that you should understand is I'm not just here to solve this linear equation. I want to use this equation to explain some things to you that you might not have known even though you might have done math for a long time. The first thing is I want to talk about what is a linear equation. Well, it's an equation is any kind of mathematical sentence that has an equal sign in it. And so what we're saying here is, and because it has an equal sign, we have a left side of the equal sign and we have a right side of the equal sign. And what this means is that whatever is over here on the left side is equal to whatever is over here on the right side. When I say equal to, I mean that it is the same thing as. So there is something that when you add 2 to it, it is the equivalent of whatever's on the other side, which is 9. So this right here, if you were to add it together, would equal 9, because 9 is equal to 9. So there is some number that when you add 2 to that number, it's equal to 9. And you probably already know what that number is, but we'll get to it in a few minutes. Okay? So that's what an equation is. Well, why is this a linear equation? We know it's an equation. Why is it linear? It's linear because the variable that is in the equation is to the first power. This is t to the first power. It's not t to the second power. If it was t to the second power, it would look like this, and we would say t squared. It's also not t. It's not t to the third power. It's not t to the fourth power, or t to the 1/2 power, or t to the 0.01 power. It is t to the first power. And when we have a variable to the first power, or any mathematical element to the first power, we don't write the exponent. We just leave it. We leave no exponent on it. Now, we don't say, however, that this has no exponent. It does have an exponent, and the exponent is 1. So any equation where the variable is to the first power, we call that a linear equation. Now, you can actually have a second variable in a linear equation. Let's say that we had t plus 2 is equal to 9 plus v. This is still a linear equation because not only is t to the first power, but v is also to the first power. And as long as the two variables in your equation are to the first power, it is a linear equation. Okay? Now, the big difference between without the v and with the v is, without the v, we have one solution to this linear equation. Only one solution. But when we put a second variable in this equation, we now have an infinite number of solutions. For example, let's say that v was equal to 3. 9 plus 3, that's 12. This would have to be equal to 12 also, so t would be equal to 10, because 10 plus 2 is also 12. On the other hand, we could say that v is equal to 11. 9 plus 11 is equal to 20, in which case t would be equal to 18, because 18 plus 2 is also equal to 20. And so, if there are two variables in one linear equation, then you have an infinite number of possible answers. And that's why this would actually be referred to as a function, a linear function. And you could draw a straight line on a graph that would show all the combinations of t and v as the answers. Okay? So now there's a rule in math that says for every variable that you have, for every variable you have in an equation, you need that number of equations to have only one solution. So if we had another equation down here that said v plus t was equal to, let's say, 100, then we could solve. We could have a solution, just a single solution, only one value for t and one value for v, because we have two equations and we have two variables. Okay, so but we're only dealing with one equation, and we're also only dealing with one variable. So now we know what a linear equation is, and we know and we also know that in order to have a solution, we need to have only one variable in the linear equation. So now let's talk about how we solve linear equations. You probably already know what to do to this. In fact, if you've already taken several math classes, if you're in high school or if you're maybe in college or even beyond college, you probably already know that the way you would solve this is you would subtract 2 because this says plus 2, so you're going to subtract 2, because your teachers have taught you that that's how you solve an algebraic equation, right? Or that's one way to solve an algebraic equation, is you subtract 2. But there is a rule in algebra that you have to follow, and that is do the same to both sides. And I call this, and a lot of people call this, the golden rule of algebra. Whatever you do to one side of the equation, you have to do exactly the same thing to the other side of the equation. Don't change it up. Don't do minus 2 on this side and then plus 2 on this side. That's not how you do algebra. That's not how you solve an algebraic equation. If you're going to minus 2 on this side of the equal sign, you also have to minus 2 on the other side of the equation. So the rule goes that whatever you do to one side, you have to do exactly the same thing to the other side. And this is one of the reasons why I tell students that it doesn't matter what you do to the equation. As long as you do the same thing to both sides, and as long as you do it correctly, you can do anything you want. I can solve this equation. I can say, well, I would like to multiply both sides by 5. Both sides. And you might say, no, that's not what you're supposed to do to solve this. And I say, I don't care what I'm supposed to do. It's still an equation. It's still the same value as long as I do whatever I do correctly. So if I distribute this 5t, 5 times 2, I would have 5t plus 10 equals 45. This is still basically the same equation. It'll still give us the same solution for t. Okay? And so, in algebra, as long as you do the same thing to both sides, you can do whatever you want. Add, multiply, divide, subtract, whatever you want to do. As long as you do the same thing to both sides, it'll still be, basically, the solution will still be the same for the equation. Okay? But what I want to teach you how to do is how to move toward a solution, not away from a solution. So let's go back to our original linear equation, which is t plus 2 equals 9. All right, so with t plus 2 equals 9, what you were thinking is subtract 2 here and subtract 2 here, and you are correct. And the reason that you learned that is very likely that what you learned was that you do the opposite of whatever is being done to the variable, right? So the opposite of addition is subtraction. That's why we're going to minus 2. Adding 2, opposite is minus 2. But I'm going to propose a different way of understanding that very same thing. The way that I do algebra is I don't think in opposites, I think in what are called inverses. And so that's why the way that I solve equations is I remember to do the same thing to both sides, and the way that I do things is I apply an inverse. I apply an inverse. The reason I'm going to say apply an inverse is because understanding inverses is larger than understanding opposites. It's specific, but it's also larger. See, everybody understands that the opposite, not everybody, lots of people understand that the opposite of addition is subtraction. And lots of people understand that the opposite of multiplication is division. But what is the opposite of an exponent? What is the opposite of a radical? People have a hard time with that sort of thing sometimes. What is the opposite of a trigonometric function? That's frustrating. I don't know. Some people might say that the opposite of sine is cosine, and it is not. And so, or they might say that the opposite of tangent is cotangent, also not the opposite. We're not dealing in opposites, we're dealing in inverses. And the inverse of sine is sine inverse, and the inverse of tangent is tangent inverse, or arctan. Okay, so we're going to remember to deal in inverses. Now, the inverse of addition is subtraction. And the inverse of multiplication is division. So you're still going to be doing things correctly. If you think of it in terms of inverses instead of opposites, then when you get to a little bit of higher level math, you'll remember you're not doing the opposite, you're doing the inverse. Okay? So we have to talk about two kinds of inverses. We have additive inverses, and we have multiplicative inverses. Okay? Well, what is an additive inverse? The additive inverse of a number is the number that if you were to add them together, you would get 0. So let's think of the number 5. What can I add to the number 5 to get 0? Negative 5. Because 5 plus negative 5 is equal to 0. And so, negative 5 is the additive inverse of 5. So what's the additive inverse of positive 2? Negative 2. And that's why we put a negative 2 on here. We're basically adding negative 2, or we're subtracting 2. We are applying an additive inverse, and that's how we're going to cancel the 2. So, over here we applied the additive inverse of 2 is negative 2. So that's going to, this is going to become 0. That's going to become 0. And therefore, it's gone. Once it becomes 0, it's not there anymore. So we're going to carry down the t. And so we have t. We're going to carry down the equal sign. Then 9 plus negative 2 is 7. Or 9 minus 2 is 7. And therefore, t is equal to 7. And we have a solution. Okay? So, by applying an additive inverse, we have solved this linear equation. Let's try another one. Let's say that we have m minus 4 equals 6. Okay? Now, we have the variable. We're trying to solve for this. And typically, the way that you solve algebraic equations is you try to move everything away from the variable. Move everything to the other side of the variable so that you leave the variable by itself. That's called isolating the variable. You want to isolate the variable. You want the variable to be by itself. Okay? So, we've got a minus 4 with the variable, so we want to get rid of this negative 4. Well, what is the additive inverse of negative 4? It's positive 4, because negative 4 plus positive 4 is 0. So we're going to apply an additive inverse and add positive 4. We're going to add positive 4 on the other side, because the golden rule of algebra is whatever you do to one side, you have to do it to the other side. And here, negative 4 plus 4, that's 0, so it cancels out. We call that canceling out. When we cancel by additive inverse, the value becomes 0. We cancel it out, it's gone. And so now we just bring down the m, bring down the equal sign. 6 plus 4 is 10, and we have a solution. M is equal to 10. Now you can go back and make sure, they call this checking your answer. Take your answer and put it back in for the letter. What is 10 minus 4? It's 6, right? And so it equals 6. So we're good to go. All right, let's try now another example. Let's say that we have 3x is equal to 21. 3x is equal to 21, and we want to solve this. Now, if you've already learned how to solve linear equations, you probably already have a technique for solving this. And what I would do the same thing that you would do. So let's go ahead and do it, but then I'm going to change it up and talk about it. You're going to say divide by 3 on both sides, because that's what I would do too. Dividing by 3, why? Well, because in this linear equation, what is this 3 doing to this x? It's multiplying, right? That's 3 times x. And 3 times x is equal to 21. So what's the opposite of multiplication is division, and that's probably one of the ways that you might have learned it. So we're going to use the opposite of multiplication, which is division, and we're going to divide by 3 on both sides. 21 divided by 3 is 7. Over here, 3 divided by 3, that equals 1, right? And that's why we cancel the 3. When we divide the number by itself, it divides into 1. See, when you cancel by additive inverse, it becomes 0. But when you cancel by multiplicative inverse, it becomes 1. It cancels down to 1. Why is that important? Because we want a 1 in front of the x. When we have just x equals, this is really 1x equals. Anytime you solve for a variable in algebra, if it's m equals, it's 1 times m equals. And if you saw one of my other videos on the rules of exponents, I talked about how whenever you have a variable or a number, it is always being multiplied by 1. All numbers, all variables, always being multiplied by 1. And therefore, there's a 1 in front of this x. And the way that 1 gets there or is left there is by canceling the 3 that's there. So we divide the 3 by 3, leaving a 1 here. Okay? And then 21 divided by 3 is 7, and we have a solution. So you know how to do that, but now I'm going to explain it in a different way. I'm going to talk about it as a multiplicative inverse. What is a multiplicative inverse? A multiplicative inverse is a number that when multiplied by its multiplicative inverse, the answer is 1. Okay? And the multiplicative inverse is always, let's see, multiplicative inverse has a special name. Or it doesn't have a special name per se. It is the same thing as another word. The multiplicative inverse of a number is what is called the reciprocal. That's an E. The reciprocal of a number. Let me show you how a reciprocal works. Let's say that you have the number 4/5. What is the reciprocal of 4/5? Reciprocal basically means to take a fraction and flip it over, okay? So 4/5, the reciprocal of 4/5 is 5/4. You put the 5 on the top, you put the 4 on the bottom, that's your reciprocal. So when you multiply reciprocals times each other, the answer is always 1. Watch this. 4/5 times 5/4. 4 times 5 is 20. 5 times 4 is 20. 20 divided by 20 is 1. Multiplicative inverses. Reciprocals. So basically, the way that you cancel multiplication is by multiplying by the reciprocal of the number. But what's the reciprocal of 3? Okay, let's look at that. The reciprocal of 3. 3 is a number. But remember, this is something you always have to remember. All numbers, in addition to always being multiplied by 1, all numbers are also always divided by 1. So this 3 is the same thing as 3 divided by 1. It's 3/1. So 3 is the fraction 3/1. And the reciprocal of 3/1 is 1/3. And if you were to multiply 3 over 1 times 1/3, you would get 3 times 1 is 3, 1 times 3 is 3, and that equals 1. Okay? So, one way of solving this 3x equals 21, instead of dividing by 3, we can multiply by 1/3 on both sides. 1/3 times 3 is 1. X equals 21 times 1/3, which is 7. And now we can get rid of the 1, and it's x equals 7. Now, here's the thing. I don't really want you to solve that problem the way I just did. Do it the old way, where you divide by 3. That's good. Keep doing it that way. I just want to show you that dividing by 3 means the same thing as multiplying by 1/3, because 1/3 times 3x, isn't 3x the same thing as 3x over 1? And so, if we multiply these, 1 times 3x is 3x. 3 times 1 is 3. And now it looks just like it did when you divided by 3, right? It's the same thing. So, if I solve this problem, and if you see this problem, the best way to solve it is to just simply divide by 3 on both sides. But I want you to understand that when you do that, you are doing a multiplicative inverse. And the answer is 7. Okay? So, multiplicative inverse. Now, I want to show you a situation where it's better to do the multiplicative inverse instead of the division by. What if, let's say that you had 3/7 x is equal to, let's see here, is equal to 12. Let's try that. I'm not sure if it's going to work out, but let's give it a shot. Let's say 3/7 of x is equal to 12. Let's make it even worse. Let's make it terrible. Make it 11. Okay? Now, based on the procedure we just used, whenever you multiply by, when something's being multiplied by x, you divide by that number, right? Well, what is x being multiplied by? It's being multiplied by 3/7. So we should divide by 3/7, right? And we should divide the other side by 3/7. Does this make you happy? Does it make you happy that you just created a complex fraction? Nobody in their right mind likes complex fractions. This is not fun. This is not something that somebody wants to solve. And therefore, instead of dividing by the coefficient, why don't we just multiply by its reciprocal? That's going to give us the right answer. So instead of dividing by 3/7, instead we can multiply by the reciprocal of 3/7, which is 7/3. And we'll do the same thing on this side, multiply by 7/3. Over here, 7 times 3 is 21, 3 times 7 is 21. This cancels out. And all we have left is x. 11 times 7/3, we're going to do 11 times 7 is 77 over 3, and we have a solution. 11, 7, and it's okay for your solution to be a fraction. It's also okay for your solution to be an improper fraction. You do not have to reduce this. Typically, in an algebra class, you don't have to reduce improper fractions. Now, if your teacher tells you to simplify or to reduce or to turn it into a mixed number, then you go ahead and do that. But I don't really do that with my students. Just know that this is a correct solution. So, we have learned how to solve a linear equation by applying an additive inverse and by applying a multiplicative inverse, which is pretty much all you have to do. But I do want to show you another one-step equation that you might face that is very similar to the one we just saw. What if this time our equation looks like this? X over 5 is equal to 3. X over 5 is equal to 3. Now, what's happening to this x is it's being divided by 5. And what you learned how to do when you were probably in middle school or something is the opposite of division is multiplication. If this is being divided by 5, then we should multiply by 5, and that is correct. We're going to multiply by 5 on both sides. That's going to cancel the 5 in the denominator. We're going to carry down the x, and 3 times 5 is 15. and we have a solution. Okay? Here's what I'm trying to get you to understand from this example. A lot of students sometimes have a problem understanding that multiplying by a denominator blows the denominator out of the water. It's gone. Multiply by a denominator, it eliminates it completely. Okay? So if you don't like fractions, you want to get rid of a denominator. That's how, by the way, that's how you get rid of a fraction. The way you make a fraction not a fraction anymore is you simply get rid of the denominator. Once the denominator is gone, it's not a fraction anymore. It's just a regular number. So if you ever want to get rid of a denominator, all you have to do is multiply that fraction by that denominator. And in algebra, you're allowed to do that, as long as you do it to both sides. So we're going to see some examples of multiplying by the denominator so that we can get rid of denominators. Okay? So let's do another kind of example. Let's see here. Let's say that we have, let's do what are called multi-step equations. That's where you have to do maybe an additive inverse and a multiplicative inverse in the same problem. Let's say that you have 2x plus 6 is equal to 13. Okay? 2x plus 6 is equal to 13. Now, in this case, we can see here that we're going to have to apply a multiplicative inverse because of the multiplication. We're also going to have to apply an additive inverse because of the plus 6. And so now the question comes up, which of the two should I do first? Now in this problem, it actually doesn't matter. This kind of problem, you could get away with doing either one of them first and you'd probably be okay. But if it's more complicated, then you might not like it so much. What if it was 2x plus 11 equals 23, let's say, okay? Let's say 24 equals 24. You would not like doing either one first in this particular case. I know why. You may not know why, but I know why, okay? And it doesn't matter whether you know or not. But here's what I want to tell you, is that when I am solving algebraic equations, I usually, unless I know something weird is going on, usually I do all my additive inverses first, then I do all my multiplicative inverses second. All of my additive inverses first, and then all of my multiplicative inverses second. Now there is one more rule that doesn't apply in this problem, and I'll show that to you in just a few minutes. Okay? All right, so multiplicative inverse, additive inverse. I'm going to do my additive inverse first. The additive inverse of 11 is negative 11, and I'm going to do it to both sides. So that's going to cancel here, carry down the 2x, carry down the equal sign. 24 minus 11, that's 13. Now I can do my multiplicative inverse. 2 times x, so I'm going to divide by 2, and I'm going to do it the same thing to both sides. Divide by 2, cancel the 2, carry down the x, 13 over 2. Okay? And there's my solution. All right? Now let's do one where there's kind of an extra step that you're not sure about. Well, you might not be sure about it. I'm sure about it. Maybe you are sure about it. Let's find out. What if I had a problem that said 7y plus 4 is equal to 6 minus 2y? 7y plus 4 is equal to 6 minus 2y. This now is a situation where there are 2 variables, but it's actually not 2 variables, it's only 1 variable. When the same letter is repeated, that doesn't mean that there's another variable. It just means that the same variable is being repeated. But we can usually put those together in some way. So this really only counts as a 1 variable equation. Even though you see the 2 letters, it's the same letter twice. In order to be a 2-letter equation, you actually have to have two different letters, like y and v, or y and x, or y and t, or x and t, or something like that. All right, so whenever you have multiple letters, if they are to the same pattern, now it has to be linear, okay? We're not dealing in quadratics here. These are only linear equations. So if you have a linear equation that has the same variable more than once, what you want to do is you want to first, before anything else, combine all the letters into one so that it's only once, there once. And the way you do that is by combining like terms. See, this can be combined with this. But here's what you want to be careful about. I know what you're thinking. Well, you may be thinking that you should do 7y minus 2y. But no, you can't do that. The reason you can't do that is because they are on opposite sides of the equal sign. You cannot combine that 7y with that minus 2y. You have to use algebra. You have to apply an additive inverse or a multiplicative inverse. And in this particular case, it would be an additive inverse because this says minus 2y. Now, you could, this is positive 7y, so you could subtract 7y here and subtract 7y here. Or you can add 2y here and add 2y here. My general rule for myself is I always cancel out the one that has a negative. So if one of them is positive and one of them is negative, I cancel out the negative. If they're both positive, then I usually cancel out the smaller one. If they're both negative, then I usually cancel out the one that has the larger magnitude. So like if this said negative 7y and this is negative 2y, this is the one I would cancel out. If they're both negatives, I would cancel out the one with the larger value in front of it. It's a magnitude of 7. Okay, because negative 7 actually is not larger than negative 2. Negative 7 is a smaller number than negative 2. Okay, but in this case, we got a positive, we got a negative, so I'm going to get rid of the negative. So the inverse of negative 2y is positive 2y, and I have to do the same thing to both sides. So I'm going to add 2y to both sides. On this side, it's going to cancel out. I'm going to carry down the equal sign, carry down the 6. I didn't do anything to the 6. If there's an element that you didn't do anything to, it just carries down to the next level. So I'm just going to carry down the 6, then I'm going to carry down the plus 4, and then this 7y plus 2y, that adds together to equal 9y. We're combining like terms. Okay? And so now it looks kind of like what we saw before, the last problem we did. And so we're going to get rid of we're going to do all of our additive inverses first. We just did one additive inverse. Now we're going to do another additive inverse. The additive inverse of plus 4 is minus 4. And I have to do minus 4 to both sides. That'll cancel the 4, carry down the 9y, carry down the equal sign. 6 minus 4 is 2. And now, last step, no more additive inverses. Now we'll go to the multiplicative inverse. We'll divide by 9 here, divide by 9 here, cancel, bring down the y, bring down the equal sign, and this does not reduce. Our answer is 2/9, and we have a solution. Okay? So I hope that helped you a good bit. Now we're going to move on to something that might be a little more complicated. Okay? What I'm going to do now is I'm going to introduce grouping symbols. And I'm sure you probably have some sort of massive hatred for grouping symbols, but here's what I want to show you. Let's say that we have 5 times x, well, let's make it a little more complicated. Let's do 5 times 3x minus 6, let's make it a 7. I don't like it when you can, examples where you can factor something out. So let's say 3x minus 7. Plus 1 is equal to, let's say, 9x plus 4. Okay? We've got a lot going on in here. Here's my recommendation. There are several ways that you can solve this. There is never only one way to solve an algebraic equation. Okay, now your teacher may disagree with you, or may disagree with me, because your teacher wants you to do it in one particular way. That's fine. If your teacher wants you to do it in one particular way, then by all means, do it the way your teacher wants you to do it. But the truth is that there is not only one way to solve an algebraic equation. There are an infinite number of ways to solve an algebraic equation. Not all of them are short. Some of them might take you a really long time. But I'm the kind of person, sometimes I don't care how long it takes me to get an answer as long as I get an answer. Okay? So what I would do in this particular case, if I'm dealing with parentheses that have multiplication on the outside, I am the kind of person who will distribute the multiplication, then get rid of the parentheses, and then I'll deal with the equation normally the way I already know how afterwards. So I want to get rid of these parentheses. But do you see this 5? This is 5 times everything inside of here. So I have to distribute, because in the house of math, multiplication lives over top of addition and subtraction. And because multiplication lives over top of addition and subtraction, multiplication and division can be distributed over addition and subtraction. And therefore, this can be distributed over 3x and minus 7. So the 5 has to be multiplied by 3x, and it also has to be multiplied by minus 7. So 5 times 3x, that's 15x. 5 times negative 7, that's negative 35, plus 1 equals 9x plus 4. There's a couple things we can do here first. I would like to combine like terms here. This negative 35 plus 1, these are like terms. So we can go ahead and add negative 35 plus 1. So that becomes 15x. Just carry that down. Negative 35 plus 1 is negative 34. Carry down the equal sign. Carry down the 9x. Carry down the 4. Now, I have two x's, okay? Two terms that have x's in them, so I can combine them. But they're both positive, but this one over here is smaller than this one over here. So this is the one that I want to cancel. This is a positive 9, so I'm going to apply an additive inverse. The additive inverse of positive 9 is negative, or excuse me, not positive 9, positive 9x. And the additive inverse is negative 9x. And whatever I do to one side, I have to do to the other. So I'm going to apply negative 9x to the other side. On this side, it's going to cancel. I'm going to carry down the equal sign, carry down the 4, carry down the negative 34, and then this, 15x minus 9x, is 6x. I'm getting closer to a solution. You might be thinking to yourself, oh, that's a lot. That's what's the saying they say now? That's so extra. Look, there is no a lot. There's no extra. It's just a problem. It's one step at a time. I don't care if it is a 150-step equation. If you carefully, one step at a time, do apply one inverse at a time correctly to both sides of the equation and just keep doing that with all the layers, each step carrying down the equal sign, carrying down the numbers that you didn't use, eventually you will come to a solution. If you are patient and you endure and you persevere through the solution, you will come to a solution, and it should be correct. Okay? Doesn't matter how many steps it's going to take. So here, we still have an additive. We have something being subtracted, so we're going to apply an additive inverse. Again, we're going to keep applying additive inverses until all we have left is multiplication and division and other kinds of stuff. So additive inverse of negative 34 is positive 34. Do the same thing to both sides. We're going to cancel on this side, carry down the 6x, carry down the equals. 4 plus 34 is 38. Divide by 6 on both sides. We're now on to multiplicative inverses, and we have x is equal to 38 over 6. Now, 38 and 6 are both divisible by 2, so we can divide the numerator and denominator by 2. 38 divided by 2 is 19. 6 divided by 2 is 3, and we have a solution. X is equal to 19 over 3. We're good to go. Okay. All right, let's do one more kind of crazy problem that you may hate, but it's going to help you to understand algebra. It's going to help you to be better at solving linear equations. I forgot to write something over here. You may want to write it down, and that is additive inverses before, this is just me, this is my way of doing it, before multiplicative inverses. That's my own personal way of solving them. You don't have to do it that way, but I promise you, if you do it this way, the reason I do it that way is because it's easier than doing multiplicatives and then additives. Okay? Well, usually it's easier. Okay, let's look at one more kind of problem, sort of a crazy, crazy kind of problem. Let's say that we have 2x minus 3 over 4 plus 7 is equal to x plus 5 over 5. That's good. That's pretty good. All right. This is a little scary. Here's the problem, is that we have fractions, 2 of them, and a non-fraction. Nobody likes to mix fractions and non-fractions. Okay? This is legitimately annoying, maybe a little scary, but I'm going to show you how I would solve this. It's going to take a few steps, but if you do it correctly, you'll be fine. I don't know if you remember me saying just a few minutes ago that the way that you cancel a denominator is by multiplying by that denominator. But there's also a rule in algebra that says that whatever you do to one side of an equation, you have to do it to the other side of the equation. So here's the idea. We want to cancel this denominator of 4, so we're going to have to multiply by 4. But we have to multiply each term by 4. We have to multiply this fraction times 4, the 7 times 4, and we have to multiply this fraction times 4. So that's what we're going to do. Also, we want to get rid of this denominator of 5. So we got to multiply this fraction times 5, this 7 times 5, and this 2x minus 3 over 4, that fraction times 5. But that sounds really clunky and annoying. If you only do one at a time, usually you'll find you can clean it up as you go, and it's not as difficult as you think. So basically what our strategy here is to first multiply by 4, then multiply by 5, and we'll see how it goes. So we're going to multiply by 4 first. Now, when we multiply by 4, we have to multiply the whole side by 4. That means we have to distribute, because we have addition going on in the left side of this equation. And because addition lives on the first floor of the house of math and multiplication lives on the second floor of the house of math, multiplication can be distributed over addition. So we have to multiply this 4 times this whole fraction and multiply the 4 times the 7 over here. So we've got 2 multiplications. Now here's the good news. If we multiply 4 times this fraction, all it's going to do is cancel the denominator. I told you that before. And I know there's someone who's watching right now who's thinking, yeah, but aren't you supposed to multiply the 4 times the 2 and times the 3? Okay, we're going to take a break for a second, and I'm going to show you why that's not the truth. All that's happening here by multiplying by 4 is we cancel the denominator, and all we have left is 2x minus 3. We just carry it down. Let me show you why. Let's say I multiply this 4 times the 2 and the negative 3. 4 times 2 is 8, so that's 8x. 4 times negative 3, that's negative 12. And it's still over 4. This is the same thing as 8x over 4 minus 12 over 4. Well, look, 8 divided by 4, that's 2. So that's 2x. And minus, and 12 divided by 4 is 3. Look, 2x minus 3. That's exactly what I brought down. And here's what I'm explaining to you, is that when you multiply, I'm proving to you, or I'm showing you, that when you multiply by 4, a fraction times its denominator, the only thing it does is eliminate the denominator, and then the numerator stays the same and just carries down. So if I multiply this 4 times this fraction, all that's going to happen is the numerator is going to be brought down. Now I'm going to multiply by 4 times 7, which is 28. So I'm going to put plus 28. Now, over here, I also have to multiply by 4. But when you multiply a fraction times a number, and the number you're multiplying by is not the denominator. If it is not the denominator, then you cannot cancel the denominator. This 4 will not cancel this 5 in this denominator. So instead of canceling the denominator, in this particular fraction, instead, we're going to distribute the 4 into the numerator. We're going to multiply the 4 times the x, then we're going to multiply the 4 times the 5, and we're going to leave it over 5. So 4 times x is 4x. 4 times 5 is plus 20, divided by the 5 stays the same, over 5. So that was our first step. Our first step was multiply 4 times both sides, and what we accomplished here is we got rid of the first one of the denominators. We accomplished something else too. Watch this. See this minus 3 plus 28? These are like terms. They can be combined. So we're going to do that now too. We've got the 2x minus 3 plus 28. Negative 3 plus 28 is 25. And now it's equal to this, it's equal to this fraction, which stays as 4x plus 20 over 5. Okay. Now we're ready to get rid of the other fraction. So how would we get rid of this denominator in this fraction? We're going to multiply by 5, right? So if we multiply this side times 5, if we do that, we have to multiply this side over here also times 5, and then it'll make it even easier. And again, you might be thinking this is a lot of steps, and I told you it doesn't matter how many steps there are. If you just do them one at a time, slowly, carefully, endure, persevere, you will come to a solution. And you will teach your brain how to be patient and how to take its time with coming to a solution. Okay? So look, 5 times this fraction, all it's going to do is cancel the denominator. So just carry down the numerator. So we have 4x plus 20. Over here, we have to distribute the 5 over the 2x plus 25 because multiplication can distribute over addition. So 5 times 2x is 10x, and 5 times 25, that's 125. Okay? You may need a calculator for that one, but you know, after you've done it for a while, you got it. Now, this looks just like something we did about 20 or 25 minutes ago. We want to get rid of one of the x's here. Okay, the 4 is smaller than the 10, so I'm going to apply an additive inverse. The additive inverse of positive 4x is negative 4x. And whatever I do to one side, I have to do the exact same thing to the other side. So minus 4x here and minus 4x here. On this side, it's going to cancel the 4x, carry down the 20, carry down the equal sign, carry down the 125, the plus 125. And here, 10x minus 4x, that's 6x. Now, one more additive inverse. We got this plus 125. We want to move it away from the x. So we're going to minus 125 here. We're going to minus 125 here. On the left side, it's going to cancel. We're going to carry down the 6x, carry down the equal sign. 20 minus 125 is negative 105. And I'm going to bring this over here now. 6x equals negative 105. Okay? Now, multiplicative inverse. We want to get rid of this is 6 times x, so we're going to divide by 6 on the left, divide by 6 on the right, cancel the 6 on the left, and we have x is equal to negative 105 over 6. Now, the numerator and the denominator can both be divided by 3, so we're going to go ahead and do that. 105 divided by 3 is 35. So we got negative 35 over 6 divided by 3 is 2. So the answer is negative 35 over 2. X equals negative 35 over 2. And now, somebody in my class asked me a question about negative fractions. And so I thought right now would be a really good time to explain what I explained to that student. The student asked me, if we have negative 35 over 2, should it be written as negative and then 35 over 2? Or should it be written as negative 35 over 2? And then I threw in another option, a third option, which is 35 over negative 2. And here is my answer. My answer is all 3 of them are correct. They all mean the same thing. Each one of those is the same value. You could put the negative in front of 35 over 2. You could put the negative in the numerator. Or if you wanted to, you could put the negative in the denominator. But we usually do not put the negative in the denominator. We just normally don't do that. We usually either put it in the front of the fraction or we put it in the numerator. Okay? And so that's the answer to that. All right, well, that's all I have for solving linear equations. I'm going to make a separate video, which is not going to be very long. I'm going to make a separate video for solving literal equations. And I think that that way you don't have to watch both of them if you only need to watch one of them. Okay? All right, well, that's it for solving linear equations, and I'll see you in the next video.